Here's a second video on an exponential function. Y equals 2 times 0.8 raised to the x power. So to determine if this is a growth or decay, we want to look at the base that is with the exponent of x. So you see that x is attached to that 0.8. So anytime that that base, right there, that 0.8 is less than 1, you're going to have a decay. So if that number is greater than 1, growth. If it's less than 1, decay. The y-intercept, two ways to find a y-intercept. You can take your x and plug in a 0. When you plug in a 0, 2 times 0.8 raised to the 0 power, you're going to get back 2. The y, that also will be this number that's out in front of the 0.8 every time. If you think about y equals, I don't know, maybe ab to the x power, it's always going to be that first one. Not the one that has the exponent with x, but the one before it. All right, the growth factor is going to be the base of your exponent. So the x is attached to the 0.8. So that is our growth factor, 0.8. All right, so we've got a table of values to fill in, and we can use our calculator on this. So all you're doing on this is plugging in the values for x. So y equals 2 times 0.8 to the negative 7 power. And you can type it in with the parentheses exactly where they are. That calculator will do exactly what you need. And when you do that, you should get back a 9.5. So for the negative 7, we have 9.5. That's a 5, even though it doesn't look like it. All right, then a negative 1. So y equals 2 parentheses times 0.8 to the negative 1. And we type that in, we get a 2.5. So I'll put 2.5 in our table. All right, we have y equals 2 times 0.8 to the 0 power, which we talked about above. That's going to be your y-intercept, and we do get back a 2 on that one. Let's see, next one, y equals 2 times 0.8 to the first power. Plug that in, you're going to get a 1.6. And last we have y equals 2 times 0.8 to the 6th power. When you do that, it gives you a 0.52. All right, so now to graph these values on the graph, I'm going to go ahead and zoom in. Starting with the negative 7, so negative 7, from the origin we go to the left 7, and then we're going to go up 9.5. That's actually off my graph a little bit, but I can estimate. 9.5, my graph goes up to 7, so I'm going to go to the left, 7, and up, here's up 7, 8, 9.5 is going to be right around there. So I'll go ahead and plot that point. Then we have negative 1 and 2.5. So the x is negative 1, the y is a 2.5. So we're going to go up 2.5 and plot our point right there. Then 0, 2. So we're not going left or right at all, just up 2. And then we have 1, 1.6. So over 1, up 1.6. So 1.6 is going to be, over 1, up here, here's 1.5. It's right above 1.5. Right about there. And then if you go over 6, we go up 0.52, so just about halfway up from there. So over 6, up about a half. And we can draw in our graph. So you notice this one is curve-shaped as well. It's kind of coming in slowly here, and then it starts to curve down. This graph will slowly approach that x-axis. Like the first one, however, it's not going to touch the x-axis. It just gets closer and closer to it. So your graph will stay above the x-axis. If you read the graph from left to right, you notice if we come in on the left side, hit the graph, do you see how it's going down? That's what a decay graph will look like. So if that growth factor, that number with the x right here, If that's less than 1, your graph will be going down from the left to right. And then again, just make sure it kind of levels out above the x-axis and does not go below it. And there's an exponential decay graph.